Hey guys, today we're looking at our practice final, and there's really only four things that we want to go over. So let's just get straight into it. The first question says to answer the questions below. How many nitrogen atoms are there in NH43PO4? Alright, well, if there's a 3 outside of this parentheses, then that means that 3 multiplies inwards for both nitrogen and hydrogen. So there's actually 3 nitrogens. And we just go ahead and write 3 nitrogens. The next question is talking about another one, counting the lithiums. When you have a 5 in the front, that means there is now 5 of these lithium phosphate molecules. So each molecule has 3 lithiums, so we would multiply it by 5. If you have 5 molecules, you'd have 3 times 5, which would be 15. 15 lithium atoms. In the next question, we are trying to balance a chemical equation. So depending on which way you want to do it, maybe some of you are more comfortable with doing a inventory. So I'm going to do it that way for this problem, or for these two problems. There is iron, hydrogen, and oxygen on each side, so make them the same so that you can easily compare across. Then you start counting them. There's 1 iron, 2 hydrogens, and 1 oxygen on the reactant side. And on the product side, what we have is 2 irons, 3 oxygens, and 2 hydrogens. And now you try to compare between the left and the right and start balancing each of these atoms. The iron looks like they're not balanced. You need 2 more on the left side, or rather you want 2 on the left side. So we're going to go ahead and put a coefficient of a 2 here. For the hydrogens, these look like they are balanced. There's 2 on each side. And for the oxygen, these don't look balanced. We need more oxygens on the left side. We specifically want 3 oxygens on the left side. Now, if we put a 3 right there, that changes 2 amount of elements. That changes the hydrogens and the oxygens. So the hydrogen becomes 2 times 3, which is 6. The oxygen becomes 1 times 3, which is 3. So now, if you look at this, the oxygen is balanced, but the hydrogen is not balanced anymore. So now we want to balance the hydrogen. The right side would need more hydrogen, so what number can we change that to? We would change it to a 3, because if we put a 3 in front, now there is a total of 2 times 3 hydrogens, which becomes 6. Okay. I forgot to change that iron to 2, so let's change that to a 2. So now it's 2, 6, 3. Everything is balanced. If you want to put a 1 in front of iron oxide, you can. Alright, the last balancing equation question. We're going to do the same thing here. Draw a line right down the middle where the arrow is, and write each element on the reactant side and the product side. And count the number of each atoms on each side. On the left side, let's see, we have 2 aluminums, 3 sulfurs, 12 oxygens, 1 barium, and 2 chlorides. So we're going to go ahead and write those numbers. On the right hand side, what we have is 1 aluminum, 3 chlorides, 1 barium, 1 sulfur, and 4 oxygens. And we're going to go ahead and write those numbers. Then you start comparing each side. Is it balanced? The aluminums don't seem to be balanced. We need more aluminums on the right hand side. We need 2. And if we put a 2 in front of this aluminum chloride, that changes the aluminums to 2, and it changes the chlorides to 6. Next, we look at the sulfurs, and if you compare the sulfurs, the right side needs more sulfurs. The number right here should be 3, because the right side should have 3 sulfurs. Now, if we put this 3 in front of barium sulfate, the amount of barium becomes 3, the amount of sulfurs become 3, and the amount of oxygens become 12, and we want to make sure that we change all 3 of those elements. Now you can take a look at the next element. The next element is oxygen, and it's already balanced. Each side has 12. We have barium, and it seems that it is unbalanced. The left side needs more, and it specifically needs 3 total. So we're going to put a 3 in front of this barium chloride. If we do that, that changes bariums to 3, and it changes the chlorides to 6. So we're going to go ahead and change these numbers. Barium becomes 3. Chloride become 6. And if you look at this, bariums are now balanced, chlorides are also balanced, so the whole equation is balanced. We can write a 1 right here in front of aluminum sulfate if we wanted to. Now we move to question number 2. For question number 2, it's talking about these conversions with prefixes. So right here we have 1 megagram equals how many grams? This one, you would just require to look at this resource sheet that has the yellow label right here. We're specifically looking at the prefix mega. If you have 1 megagram, how many grams are there? If you find mega, it turns out there is 1 million of those grams. So you can either write 1 million, or you can write it with the exponents, which is 10 to the 6. So 1 megagram is 1 million grams. The next question is asking us to do a conversion. Now it's asking us to convert 9.4 hectometers to meters. Show all your work for credit here. So what we're going to do is circle what we're trying to convert to, which is meters, underline what we're starting from, which is 9.4 hectometers. And we always write down what we are starting from first. We're starting with 9.4 hectometers. We are trying to convert to meters, and anytime you do a conversion, times, draw a line. Now the unit that we write on the bottom is always going to be the unit that we start with, hectometers. The unit that we write on the top is what we're usually trying to convert to, which is meters here. The numbers that go here, you would get from the prefix, but remember there is one tip. You always write the number 1 next to the unit that has a prefix. So out of these two, hectometer, hecto is a prefix. We're going to write a 1 in front. And when we see this, we're trying to think to ourselves, okay, if we have 1 hectometer, how many meters is that? That's kind of like the first question that we answered. 1 hectometer, how many meters is that? Look at your SI prefix table, find hecto. How many meters is there in 1 hectometer? It turns out that there's 100, or 10 to the 2. So 1 hectometer, 100 meters. The unit that cancels out here is hectometers and hectometers. The unit that we're left with is meters, and that's what we want to convert to. We throw in our equal sign and type this into a calculator. 9.4 times 100, because the 100 is on top, so you multiply here. 9.4 times 100, if you type in the calculator, you should get 940, and then the unit that we're left with is meters. Alright, so make sure you show the entire work here to get credit. If you only show the answer, you're not getting any credit. Letter C. Now it's asking, how many seconds are there in 7 hours? Show all work for credit. Okay, same thing here. Circle what you're trying to convert to, which is seconds, and we are starting from 7 hours, so we go ahead and underline that. Now when you're doing a conversion, you first write down what you are starting from. 7 hours. Alright, we are doing a conversion, so times, draw a line. We usually start with the unit that we started with, and we write that on the bottom. So we write hours on the bottom. We're usually trying to write what we convert to on the top. We're trying to convert to seconds. Do we know a relationship between hours and seconds? Most people don't know this, so maybe we shouldn't write seconds on the top. We do know a relationship between hours and minutes, so we're going to use minutes on the top instead of seconds. So erase this, write minutes. Alright, what is the relationship between hours and minutes? Well, for every 1 hour there's 60 minutes. So 1 hour, 60 minutes. That's where those numbers belong. The unit that cancels out is hours. We're left with minutes, and notice that we're not trying to convert to minutes, we're trying to convert to seconds. So that means we keep going. Times, draw another line. And the unit that goes on the bottom here is a unit that we already wrote, minutes. The unit that we're trying to convert to is seconds, so we write seconds on the top. Now, do we know a relationship between seconds and minutes? We do. There is 60 seconds in 1 minute. So 60 seconds, 1 minute. That means 60 should go next to seconds, so 1 should go in front of minutes. The unit that cancels out here is minutes and minutes. This would let us convert to seconds, and that's what we want, so we can go ahead and write an equal sign. So to do this conversion, you start with 7. 60 is on the top, so you multiply by that. 60 is on the top again, so you multiply by 60 again. So we do 7 times 60 times 60. Let me get a calculator. So start with 7, multiply by 60, and multiply by 60 again. And what I'm getting is 25,200. And the unit that we're leaving off with is seconds, so we couldn't cancel that out. We have to leave it in there. Alright, on to the next one. In letter D, it's asking us to convert from 5,500 deciliters to kiloliters, and show our work, of course. Now, do the same thing, circle what you're trying to convert to, underline what you're starting from, and first write down what you're starting from. Okay, now recall for this problem that there are actually 2 prefixes here, and what we've stated about this is if there are 2 prefixes, you have to do 2 conversions. It's similar to letter B. Letter B only had 1 prefix, so you do 1 conversion. So just know that we're doing 2 conversions here. The first conversion, the unit that goes on the bottom is the unit that we started with. It's deciliters, DL. The unit that we're trying to convert to, it would be nice if we knew how to convert to kiloliters, but we don't know the relationship between deciliters and kiloliters. So we convert to the base unit, which is liters, the unit without the prefix. And as before, you put the 1 in front of the unit that has a prefix, which is deciliter. So 1 goes in front of deciliter. How many liters are there in 1 deciliter? Look at this resource. Find deci. And in front of deci, for 1 deciliter, there is 0.1 liters. For every 1 deciliter, there is 0.1 liters. The unit that cancels out here is deciliters and deciliters. We are left with liters, but we still want to convert to kiloliters. So we keep going. Times, draw a line. Oops. The unit that goes on the bottom is liters, because that's the one that we're starting from here. The unit that goes on the top is a unit that you're trying to convert to. We are trying to convert to kiloliters. The hint was to write a number 1 in front of the unit that has a prefix, which would be kiloliters in this case. So 1 kiloliter. If you have 1 kiloliter, how many liters is that? Again, look at the prefix resource. If you had 1 kiloliter, how many liters is that? Find kilo. If you had 1 kilo, it's 1,000. So 1 kiloliter is 1,000 liters. Okay, so 1,000 goes on the bottom here. The unit that cancels out is liters and liters. We are left with kiloliters, which is what we want. So we can go ahead and throw in our equal sign. And let's see. We are trying to type this in a calculator. 5,500 times 0.1 divided by 1,000. So type that in your calculator. And what I am getting, do this one more time. What I'm getting is 0.55. There is 0.55 kiloliters when you have 5,500 deciliters. 0.55 kiloliters for every 5,500 deciliters. Alright, and that's how we show our work for this problem. Let's move on to the next one, which is number 3 on the back page. It says here, use the following chemical equation to answer the questions below. Letter A. Look at the balanced chemical equation above. How many moles of CO2 is produced if 1 mole of C5H12 reacts with 8 moles of O2? It says here you don't need to do a conversion here, just interpret the chemical equation. So the way we interpret this chemical equation is that there's 1 mole of C5H12 reacting with 8 moles of O2, and it's producing 5 moles of CO2 and 6 moles of H2O. Well, if we're starting with 1 mole of C5H12 and 8 moles of O2, how many moles of CO2 is produced? It's right here, 5 moles of CO2. Alright, and that's really how you interpret a balanced chemical equation. You can interpret in terms of moles. The second question is asking, what is the mole ratio involving H2O and O2? So look at H2O, look at O2. There is 6 moles of H2O, there is 8 moles of O2, so the mole ratio involves those numbers. 6 moles of H2O and 8 moles of O2. This is the mole ratio, as moles on top, moles on bottom, and those are two specific compounds it is asking us to relate. Letter C. How many moles of H2O would be produced if you started with 2 moles of C5H12? Show all work for credit. Okay, in this one, we're doing a conversion. It's a mole-to-mole conversion. Alright, when we do conversions, we normally circle what we're trying to convert to, which is moles of H2O in this case, and we underline what we're starting from, which is 2 moles of C5H12. So notice we're going from moles of one substance to moles of another substance. So start by writing what you underlined. 2 moles of C5H12. We are trying to convert here from one unit to another unit, so times, draw a line. The unit that goes on the bottom is the unit that you're starting with, which is moles of C5H12. The unit that you're writing on top is the unit that you circled already, moles of H2O. Notice that this is a mole ratio. Anytime you have a mole ratio, where are you supposed to look? Let's see. Anytime you have a mole ratio, you look at the balanced chemical equation. Look at the balanced chemical equation. Now our balanced chemical equation is on the top right here. How many moles of H2O are there? 6. How many moles of C5H12 are there? Just 1. So we have 6 moles of H2O, 1 mole of C5H12. The units that cancel out here is moles of C5H12. We are left with moles of H2O, which is what we want. So we can go ahead and throw in our equal sign. We're starting with 2. We multiply by 6. 2 times 6 is 12. And if you really think about it, does this make sense? Well, if we're starting with 1 mole of C5H12, how much H2O, how many moles of H2O are we making? We're making 6. If you start with 2 of these C5H12, how many moles of H2O are we going to make? It's going to be double the amount. Alright, so yeah, it's going to be 12. Letter D. In this reaction, how many moles of C5H12 will react with exactly 4.25 moles of O2? Okay, show all your work for this. We're going to do the same thing here. We're going to circle what we're trying to convert to. We're going to underline what we're starting from. We're going to write down what we are starting from. 4.25 moles O2. Since we're doing a conversion, times, draw a line. The unit that goes on the bottom is the unit that we're starting with, which is moles of O2. The unit that we're trying to convert to is the unit that we already circled, which is moles of C5H12. Notice that we have a mole ratio here. When you have a mole ratio, you're supposed to look at a specific place to get the numbers. If you have a mole ratio, you look at the balanced chemical equation. Our balanced chemical equation is right up here. How many moles of C5H12 are there? 1. How many moles of O2 are there? 8. 1 mole C5H12, 8 moles O2. The unit that cancels out here is moles of O2. We're left with moles of C5H12. That's what we want. Throw in the equal sign. And let's see, what we're doing here is we're taking 4.25 and we're dividing it by 8. So do that in a calculator. This is what I'm getting, 0.53. So let's see, our final answer is 0.53, and the unit is moles of C5H12. Alright, that's it. That's how you do mole-to-mole conversions. The very last one, number 4, is dealing with mole-to-mass conversions, or molar mass. So, answer the questions below. Letter A is asking, what is the molar mass of Cl? Molar mass is very easy. For molar mass, you just look at the periodic table. We're trying to look for chlorine. Molar mass of chlorine. Where is chlorine? It should be on the right-hand side of the periodic table. It's right here. And if you see that number, it's 35.45. That very bottom number is the molar mass. 35.45. And the number that you're getting is telling you how many grams there are per 1 mole of that substance. So 35.45 grams per 1 mole of chlorine. The next one's a little bit more challenging. What's the molar mass of this compound right here? Well, notice that there is 1 cadmium, 2 nitrogens, 4 oxygens. So you have to add them all up. So look up the molar mass of cadmium, nitrogen, and oxygen. And for this one, I'm going to zoom in and show you how I'm going to type in a calculator. But just know that you will not have to show your work for the molar masses here. So find cadmium. Cadmium is somewhere in the transition metal. Let me find it. It is number 48. It has a molar mass of 112.41. So 112.41. That's the molar mass of cadmium. But we still have to get the molar mass of the nitrogens and add it up. So the molar mass of nitrogen, it's right here. It says it's 14.01. So there's 2 nitrogens, so you multiply 14.01 by 2. And lastly, we add the molar mass of oxygen. There's 4 oxygens, and each oxygen is 16 grams per mole. So we add 4 times 16 grams per mole. And then you type this in a calculator, and you should get your molar mass of the entire compound. And this is what I'm getting after typing that in. 204.43. 204.43, and this is again how many grams there are per 1 mole of that substance. Grams per 1 mole of cadmium nitrite. Alright, the next problem, number 3, let's see what it's asking us to do. It's asking us to convert 6 moles of copper to grams of copper. Show our work for credit here. Okay, how do we do this? We start by circling what we're trying to convert to, which is grams of copper. We underline what we are starting from, which is 6 moles of copper. And usually write down what you underline, 6 mole copper. We're doing a conversion, times, draw a line. The unit that goes on the bottom here is the unit that you always start off with, which is moles of copper. The unit that you write on the top is usually the unit that you're trying to convert to, which is grams of copper here. This looks familiar. It is a molar mass. When you have a molar mass, where do you look to get the numbers? If you don't remember, you can look at the reference sheet. When you have a molar mass, you look at the periodic table. Alright, so we want to look at the periodic table for the molar mass of copper. Well, on the periodic table, according to this, copper is right here, and it has a molar mass of 63.55 grams per mole. So it's 63.55 grams per mole, so per 1 mole. The unit that cancels out here is moles of copper. You're left with grams of copper. That's good. That's what we want to convert to. So for this problem, we want to start with 6 and multiply by 63.55. So, I need to do that in my calculator. We got 6 times 63.55, hit the equal sign. This is what I'm getting, 381.3. Let's see, 381.3. The unit is grams of copper. So if you have 6 moles of copper, you have 381.3 grams of it. Right. Now, the next one, the last question, is pretty much the same thing. How many moles of calcium fluoride is there if you measured 82.56 grams of calcium fluoride? Show all your work for credit here. Okay, circle what we're trying to convert to. How many moles of calcium fluoride? Underline what you're starting with, 82.56 grams of calcium fluoride, and write down what you're starting with, 82.56 grams of calcium fluoride. We're doing a conversion, so guess what? Times, draw a line. The unit that we're starting off with on the bottom is right here, grams calcium fluoride. The unit that we're trying to convert to, we circled, moles of calcium fluoride. Notice here that we have a molar mass. Anytime you have a molar mass, guess where do you look? You look at the periodic table. So we want to get the molar mass of calcium fluoride. So on the periodic table, find calcium, which is right here, 40.08. Find fluoride, which is right here. It's 19 exactly. So notice how we have 1 calcium and 2 fluorides. You have to add up 1 calcium's molar mass and 2 fluorides molar mass. So just to show you how I add this up, I'm going to do it off to the side. Let's see, 1 calcium. 1 calcium is 40.08. And then 2 fluorides. 2 times 19. What does that equal? This is the molar mass of calcium fluoride. 78.08 grams per mole. 78.08 grams per mole. Alright, so that's where the numbers shall go. There are 78.08 grams per 1 mole of calcium fluoride. Now the unit that cancels out here is grams and grams of calcium fluoride. We are left with moles of calcium fluoride. And go ahead and throw in our equal sign. What it says here is we're starting with 82.56 grams. And then we're dividing it by 78.08. So in a calculator, let's type that. this is what I'm getting. Slightly above 1 mole. 1.05 moles. Okay, hopefully that's a little bit helpful. If you need help on this, please make sure you let me know. There were a lot of practice problems that we did for each of these topics, and if you need another one of those worksheets, you can visit our digital calendar and try to identify those practice problems. Good luck, you guys.